the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is for linear algebra students who are currently working with homogeneous linear systems. And this topic that we're about to delve into here, it's just about rewriting solutions in what's called parametric form or parametric vector form. So this specific video, I'm just going to have 3 pages of topics here. They're very short, each of them, so that's not going to be a big deal. But definition of a parametric vector equation, an equation of the form x, it's a vector equation, right? X equals some scalar times vector u plus some different scalar times vector v, where s and t are scalars from the real number system, is called a parametric vector equation. And I only limited it to 2 scalars here, s and t, but it actually could go to as many as we want. The equation x equals x3 times the vector v, which is equal to x3 times 1, negative 2, 1. That actually comes from a previous example we did in this lecture series, with x sub 3 being a free variable, is a representation of the solution from example 1.5, number 1, which is this problem right here. Remember, we got all the way down to this solution. Actually, we got down to this solution first. X sub 3 times the vector 1, negative 2, 1. And then at that time I said, well, let's go ahead and let x sub 3 equal t, so that our solution's actually, instead of x sub 3 times 1, negative 2, 1, it's t times the vector 1, negative 2, 1. And that's essentially what we're being asked to do here. This can be rewritten as a parametric vector equation, x equals tv, where t is in the real numbers. This is the parametric vector equation of a line through the origin in r cubed. So in other words, even though we have x equals x sub 3 times some vector, where the vector is 1, negative 2, 1, we would like to write it as a parameter times that vector. And this is actually the equation of a line going through the origin in r cubed. If you let t equal 0, it goes through 0. And then if you let t equal 1, it goes through 1, negative 2, 1. And we showcase that with a graph in that example from earlier, maybe 2 or 3 videos ago. And that leads naturally into this final definition for this topic. I told you this video is very fast. The parametric vector form. And this is just our way of rewriting a vector solution to an equation. So if I give you an equation ax equals b, if you can write it in the form a linear combination of other vectors. These vectors right here, v1, v2, all the way to v sub p, they are not the columns of A. Please do not think that. Up to this point in this course, we've been dealing with mostly linear combinations of the columns of the coefficient matrix A. Now we're not. We're saying we have some, not arbitrary vectors, but we just have some vectors that we can write our solution as a linear combination of. In this case, you have some vector x, which is actually this, x sub 1, x sub 2, all the way down to x sub n. And we're saying that we could write that as the summation of other vectors. And the weights on those other vectors, we will use indexed coefficients, but notice these indexed coefficients are not x sub 1 and x sub 2. They're c1, c2, all the way to cp. They're just some unknown coefficients. They're the unknown weights for that linear combination. But anyway, that's the parametric vector form of the solution. And that parametric vector form is going to be huge for future conversations. It may not seem that important right now in your course if you're not one of my students, or even if you are one of my students, you're probably looking at this going, what's the point of this? And I probably would ask that same question. What is the point of this? Why are we learning about this parametric vector form of a solution? And not to let too much of the cat out of the bag, but we're going to make linear combinations of solutions that we get from matrix equations in the next video. And so that's where these linear combinations of solution vectors will come into play. You'll have a main solution, which will be our general solution, if you will, and then you'll have particular solutions and solutions to the homogeneous equation, basically, is how it goes. So no need for you to know that right now, but the main thing is that you should at least be able to nod your head and say, yeah, okay, I get it, that you could probably write a vector as the sum of other vectors. You can actually do this right now with the vector, let's say 1, 1, 1, 1. That's super, super simple. Actually, let's do this. 1, 7, 11, 2. You could totally write this as a linear combination of the following vectors. And being able to do this in the future is very important because it allows us to enter conversations about spaces and stuff like that. So this is foundational to very many topics in the future. All right, but for right now, there's not much I could say that is gonna really convince you that this is a helpful item. It's just a good definitional video. All right, or maybe I should say it's a definitional video. I don't know if it's good. All right, hope to see you in future videos, and please be good humans.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.